Irina, you're up next. Signal-to-noise ratio estimation of aerial and satellite imagery. Good afternoon. As Alexander mentioned, we will look into signal-to-noise ratio estimation of aerial and satellite imagery. Digital noise is one of the factors that affects the quality of aerial and space imaging materials. This slide contains the definition of digital noise on image. And we have two images, one with noise, the other is noiseless. The noise on aerial and satellite images manifests itself in differences in brightness between two neighboring pixels. What are the causes of random noise in the image? There are several of them, and they can be broken down into two major groups. First, technical parameters of a camera, such as pixel size, photosensitivity of matrix, and temperature, a couple of others. And the shooting options, for example, exposure value. As I told you, the digital noise affects aerial and satellite images. But when we do quality control, we don't measure the level of noise, but it is very visible. For example, here you can see Canopus V image with visual noise, and the second one is aerial image delivered by DMC2, also with noticeable noise. The problem of noise on digital images is subject of numerous publications and scientific papers of predominantly international experts, not domestic ones. And there are several approaches as to how it can be estimated. You can see the formulas here. I will not elaborate on those. This is just for reference. In particular, it is considered that signal-to-noise is a standard for noise measuring, and it is measured in decibels. Another interesting method was proposed by a Russian scientist in 2012. It's Evgeny Lubchenkov, and it is based on the RMS of signal, based on harmonical analysis. Again, you can see the formula. And then you do signal-to-noise ratio. The lack of ability to interpret these images is their major setback. And this value can be considered to 70, 75, even 100. But what do those values mean? I mean, is it good or is it bad? What should be the optimal value of the signal-to-noise ratio to make it noisy? So when it comes to aerial and satellite imaging, the common practice is to standardize signal-to-noise ratio in the following way, or to normalize it. So we put it between the range of 0 to 1. And the closer the value is to the 1, the smaller is the influence of the noise. And the nearer it to the 0, the greater is the influence of the noise. To check the performance efficiency of this algorithm, we created an image of a great test pattern first one was measured as 0. Then we added different types of noise with various RMSs. You can see how this gray wedge changed. And then we made comparison of the known data and the harmonic analysis data. The results are presented in this table. We can see that using harmonic analysis driven data, we can receive normalized noise to signal ratio, which is no worse than 0.11. Since the value is not normalized and depends a lot on the underlying bedrock, it's important to know how the nature of this underlying surface affects the signal. If it's arable field or something like that, the noise to signal ratio is worse, but the quality of image does not suffer. Therefore, we created a random sample derived from different images made by Canopus V, black and white. Again, we see 5 examples of underlying surface. Urban area with multi-story buildings, some economic structures, rural areas, agricultural grounds, and relief or terrain. Here you can see the noise level assessment algorithm results. We added some noise from different levels. Similarly with the gray wedge noise levels. So we determined the noise level based on the harmonic analysis data as an RMS. Then we determined the normalized value of noise to signal, and the results showed that the normalized value of signal to noise and the surface, underlying surface, does not affect the signal. So the normalized signal to noise ratio is no worse than 0.025, and the result applies to all types of underlying surface. These are some preliminary findings. I mentioned one of those. In this example, we used panchromatic images. To determine the colored image, similar calculations are run for each spectral component: blue, red, and green. These are some practical examples based on harmonic analysis. We have images from Canopus V from 3 to 6. And Canopus images are the noisiest, and the best result was shown by highest to D, with the highest degree of signal to noise ratio. Here you can see measurements made for each of the RGB signal components. This is DMC2 camera, middle format, MCD Penta, and Sony RX, which has the worst signal to ratio. So its matrix is the noisiest. So the conclusions are: the digital noise affects the quality of aerial and satellite imagery. When assessing the quality of such imagery, it's important to carry out evaluation of noise levels in those images. To evaluate the signal-to-noise ratio, the harmonic analysis method can be used. delivering a normalized level of signal-to-noise ratio of an image, which is no worse than 0.025. And this method and proposed normalized criterion for estimating the signal-to-noise ratio will be normatively fixed in the organization standard of Roscartography. Thank you for your attention. Your questions, please. So you're supposed to take images of the same objects for comparison. I mean, different sensors, different territories. Is it viable to compare those if they're different? The reason why I picked different sensors is because we did performance test to evaluate accuracy of the method, and then with the same accuracy we receive realistic noise to signal ratio. You set aside the influence of the underlying surface, right? These are just parameters of the sensors. Anything could affect the quality, but we are measuring the noise level of the sensor. You disregarded in this method the underlying surface, right? This method is not affected by the underlying surface. You compared only Russian satellites. Don't you think it would be interesting to compare Russian satellites with Airbus satellites, Maxar, and others? I think this will be good report. Perhaps Russian satellites feature most of the noise, or the other way around. Can you share with us some images for comparison? Yes. And then before you publish the results, just let us know what the results are. You mentioned DMC3 and phase 1. But you didn't use those in your comparisons. That's because we did not receive any images taken with those cameras. As soon as we have those, we will definitely run a comparison. Roscartography is our customer. They will have those images. So at least one presentation, we'll have at least one other presentation for the next conference. Your methodology, how long does it extend the image analysis time or the cost of it? We don't have to assess the entire image, be it aerial or satellite. We can assess fragments of it. If we use fragments for analysis, then, well, time-wise, I'm not certain. I can give you the result down to a minute. I think it takes up to 10 seconds per image. Any other questions? No questions? Okay. Thank you once again.